YouTube channel. I'm recording this after many years. It's exciting. Things have been busy lately. I promise I have a plan for this YouTube channel. I'll stay more active soon. Quick career update, I've been doing my master's and completing it this month. You can check out my LinkedIn and GitHub from description. So in today's video, we will look at RAG-based chatbot. I will give a high-level overview of what RAGs are, and I will share the architecture diagram for my project. I will give you the demo. One thing which you will not see is the code. I am in talks with my university to get this implemented. Until then, this remains under proprietary license. So let's get started. So this here is OGS, Northeastern University's International Department. Any student who wants to know anything about visa or immigration, or if they want to process any form with OGS, they come here on this website. The challenge is that there are just so many things around visa, it makes it super hard to navigate and find information on this website. If I look at just for new students, these are the number of things I might want to go through before I find the information I'm looking for. The same goes with current students as well. And each of these sections have subsections within them, making it even harder to find information. OGS also has office hours, but weekends are holiday, so I can't take their help on weekends. And I can also raise tickets with OGS, but these tickets take some time to get resolved. OGS is just one of the many departments under Northeastern University. Every college has its own website and every department has its own website. For example, my college for computer science, which is Khori, they have two websites. One website is any information around Khori College. The other one has all the different courses for undergrads, PhDs, and master's student. So this here is a locally hosted simulation website of OGS, and the solution Pawsistant is a chatbot here, which is an AI powered, uses RAG in the backend to give you accurate and reliable answers. It will not answer a question if it doesn't know the answer to it, or it cannot back it with a URL. Let's say hi. So let's ask it a little bit about OPT process. So it gives you a structured response about how to apply for OPT. It says you need to complete post-OPT quiz and other steps are listed here. Next, let's ask another question. So I'm asking it to give me a URL to program completion certificate. It gives me this URL with a little bit about it. Let's check. Yes, this is the correct URL. So far, we have been using Claude Haiku as the model to get our responses. We have this settings button here with which we can swap our models. So if I click OpenAI and save it, we can now change our model. Let's ask another question. What is F2 visa? So the change in the style of response, what you see is the difference between the models we are using. This is the architecture diagram for the RAG system. First step is to process and prepare the data. So we scrape the data from the OGS website, then it goes through a cleaning pipeline. We maintain the HTML data format because it brings some structure to our input, and anything which is not a paragraph, heading, or a URL is removed from this HTML. The main part of any RAG system is how we chunk it, because that decides how well our semantic search on the vector DB is working. The chunker I've used here is semantic chunker. It chunks depending on when a specific context gets over. It prevents the context to be abruptly cut, and that is the advantage of using this type of chunker here. This data is then passed through BAI's BERT embedding. The Beijing Academy of AI BERT is just an optimized version of the BERT base. So this is then stored in the vector database. The user interface interacts with these models through Flask API. There is a red line here for Claude model and the blue line indicates GPT model interaction. What makes this system different is the vector database. Whenever there is a query from the user to any of these models, the retriever system does a semantic search between the user query and the FIRES vector DB to bring in relevant documents for these models to use for their answer. What this brings is reliability and accuracy in the responses. One thing which is different between the GPT and the Claude HiQ model is the Claude Query Optimizer. So this query optimizer, what it does is passes the user query to the LLM even before it passes it to the RAG. The LLM then solidifies the user query and then passes it to the RAG system. Claude here uses prompt engineering to give more friendly responses than GPT. This can be observed in the demo at the end of this video. So before we can start our software, we need to configure it. There is a configuration file under utils folder inside config.ini. This has a lot of different parameters and this is what the file looks like. Once configured, this software can be either run on command line or the web interface which we saw in the demo. The command line has several options. The first is if we run this specific command, we are triggering the pipeline. This pipeline is the one which cleans and scrapes all of our HTML data. To start the chatbot, we can use any of these commands. Either of these commands start the chatbot on the command line interface. Quick note that the first time we run the chatbot, it takes a little time because it's creating the vector database for us. To start the server, we will be using this specific command. We got that.